So basically, it's a case study where we want to know about the future of wind power, basically. So it's also linked with the attribution study and whether we have already witnessed changes in wind power. So far, what we did was to use the data from Copernicus Climate Change Service that was available from a previous project, and try to see what is the risk of having a winter season with very low winds, which we can call wind droughts. So this is what was done last year. And what we could look at is the change in the odds of having such a low wind winter for different countries. And it was using a limited number of models, 10 if I remember correctly, or maybe 12. So these models were bias corrected. And here we show the risk curve for low wind events. So you may not be able to see it properly on the screen, but here, for instance, for Poland, we have in blue the past curve showing as a function of return period, the return value of the wind speed. So when you go to very long return periods, you go to lower wind speeds. So you can also read it the other way, looking at low wind speed, very low wind speed, and high return periods of such extreme events. So what we wanted to do was what we want to do eventually is to link with Work Package 3, especially with for the wind, to see whether the wind power is better represented in high resolution models, especially with the orography, but also with Work Package 2. And here we would like to benefit from the new Copernicus Climate Change Service set of projections. So I'm showing here some of the results of the so-called Principles project, which has actually now about 60, in this case that was 55 models. And we did some publication of this data set. Basically, it's the RCM GCM matrix, and the gray cells are the cells that are filled. So we would like to use this ensemble of with a large number of models to assess the changes. So what we did is to look first as a case study, because we had some wind power producers in Brittany showing that, so this is a wind curve starting in 1988 and ending in 2017. And there is, of course, a decrease in the wind, and they wanted to know whether it's temporary or whether it's going to be like that in the future. So what we did was to really look at this question and look at this case study with the star at the place of the location of the wind farm. And we looked at the winters, the mean wind during the winters in the climate projections and in the observations. So here on the left, I think I can enlarge a little bit. I'm not sure you see the gray lines. So there's a black line and a gray line. Gray lines. So the gray lines are the non-bias corrected Eurocordex models, and the black line is the WFDEI. We can replace it also by ERA5 reanalysis. And this shows the sorted values of the last 20, 30 years or so. So these are historical part of the history. And what we also see in this graph is that basically it's a cumulative distribution function with the wind here on the y-axis, and the sorted value, the rank on the x-axis. And what is interesting is that now we have so many models, and with this large ensemble, that the question is whether we need bias correction or not. So this is a tricky question that we are debating, but we can also just select the models that are representing well this kind of distribution. So this is typically what we end up with the best 10 models. And what we will try to do here is to do the exercise without bias correction, which is actually what we could prefer if in this case. So it's interesting to see that we have such models which are behaving well. So there's a clear link with work package 2 that we need to make better here. And from this ensemble of models, what we could look at is the past trends. So I'm reducing a little bit past trends. So here's the observation, trends in wind. So it's a trend of almost 1 meter per second per century. So it's 0.1 per decade. That's the observations. And we have all the models and the best 10 models with red. So what we see is that, so this is historical, it has a very low signature of warming or climate change in this period. So what we see basically is that the observation is perfect. Even though we have a trend, it's perfectly compatible with natural variability. So that's one of the answer to this, for this case. And we could also look, but I'm going to move quickly, to the risk curves, which are marginally decreasing in the future. So there is no specific risk in this for this case. But now if we move to other cases we could think of is, for instance, if we had a company that would own wind farms. It's not a real company, it's just a mock-up. So if we had a company which would own wind farms in Europe, across Europe, like this, we could do the same exercise, select the best models, and calculate the risk curve, and end up with something that is still, again, a bit decreasing in the future. And actually, if we select more or less at random the location of wind turbines, that's exactly what we find in many cases, a marginally decrease of wind in the future. So now if we can go also at the country scale. If we look at Iberian Peninsula, so I'm sorry, it's 2 countries, actually 3, contains part of UK. Then we can do the same exercise, average the wind, select the best models, and in this case, as you see, I can enlarge. Eurocordex models tend to overestimate in for most models the wind here, and if we select the best 10 models, it makes the models that produce the least windy cases for Spain and Iberian Peninsula. And in this case, if we repeat the exercise with the risk curve, we get a different picture, but that's not a full surprise. That in the future, the frequency or the probability of low winters is going to increase, and increase by a large amount, by a significant amount. It's really significant in this case. It's about a factor of 3 if we look at the ratio of the curves here. So the conclusion in this case would be that over Spain and Portugal in general, there would be 3 times more low winters than there was in the past, and also a little bit currently. So this is where we are at the moment. What we want to do is to have a better organized contact with stakeholders again. This is not done yet due to difficulties in hiring, but however, we also want to use wind power production instead of winds, and link with work package 3 and 2 actually on on how wind distributions are modified by resolution. Thank you.
Thank you very much, Robert. Good timing. So I think Freya, did you have a question you wanted to ask? Can you hear me, Freya?
Yeah, no, my question was actually relating to Robert's comment about the previous presentation. So I've wrote it in the chat, so it's not very important. But maybe I can ask a question anyway. So I'm just wondering for the kind of stakeholder interactions, if what the main aim is. If the main aim is to present something that you think they might want to use, or if the main aim is to kind of highlight how some of these different methods of, let's say, ensemble reduction, etc., could, how do you want to put it, simplify or standardize, or if it's more about the process or more about the final product, is maybe my question.
Yeah, so if I may answer this, I think we are a little bit upstream of if you think about C3S and specifically C3S energy. So we are using the data from there, but also we are exploring methods of how to answer the question about change in risks, and also about specifically the first question was really yes or no. Is it due to internal variability, or is it something that we can expect in the future? This is typically the question that people ask. So for the moment, what we could answer is that it's possible that it is due to natural variability. So I think it's important for producers, and I think this project can help set up methodologies, basically, that could be used later in a more operational context. So we are exploring ways of doing things.
Okay, thank you. And Segaline, did you have a question?
Yes, Robert, it was just about how do you constrain your models? Like, the choice of the model, is based on their performance when they're driven by air entry or driven by the GCM? Because I would think that winds depend quite a lot on the GCM you choose to.
So here, the models we use are climate projections. So they are not constrained by, yes, so they are really downscalings of GCMs, and we are just selecting the models that fit best the distribution of winds, of the observed winds. So now we have a big questions about the observation of winds itself, because we know that several data sets give different results about winds, and there could be uncertainty about that. But it's we are also what we probably have to do is also investigate different reanalysis. Not only this one is basically ERA interim, but ERA 5 would give this about the same results. ERA 5 is less windy than ERA interim, as far as I understood. We could also use others to make sure that we get the stable results.
Okay, thank you. Jason, is it a very quick question?
Yeah, just a very quick question to note the overlap with work package 2 and the work they showed on possibly ruling out some of the ensemble members. It would be interesting to see if the same members are selected when you look here specifically at local winds compared to the large-scale drivers of circulation. And I think it'd be good to see that in a future talk.
I think we would be happy to connect with Work Package 2 on this issue, and this should probably be organized at the Work Package level, because I guess the same question applies to other applications.
Yes, just a quick remark. I think the regional model is also quite determining here, because a lot is downscaled to ROCMO of the best models. So probably the turbulence scheme is quite determining here.
Yes, this is true. Actually, in the paper we submitted in December on the Eurocordex evaluation, we see that the winds are essentially driven, the winds biases, to be more correct, are essentially driven by RCM, not the GCM.
Yeah.